Got a submission here from Genivos, who's flying a ZMR 250 with Betaflight 233 Alpha at 2 kilohertz. Got your PIDs here using rewrite. Nothing jumps out as unusual. Possibly, I'm not sure if your D gains are a little bit high for this version of Betaflight because Betaflight's handling of the D term changed so much in the 2.3x group, but we'll take a look and we'll see. It's also interesting to me that your gyro filter is at 60. Always interesting to see how these new changes in filters play out. But 60 is certainly a good place to be, considering that most of the useful gyro data is between 50 hertz and below, and really more like 20 hertz and below. So the real question here that I don't have the answer to is what the transfer function for the, I think it's the biquad filter that Boris is using is, and how much roll-off there is and so forth around the 60 hertz. Anyway, that's probably even the default value is probably a fine value, just sort of sharing my thoughts. I also see you've got Acro plus factor of 40, so we may see some difference in the way that your stick movements are translated to the PID controller and to the motors. We may see that the PID controller has less influence at extreme stick motions, stick deflections. So let's go ahead and take a look. And as usual, the first thing I will like to do is turn on your gyros and zoom out. And we can see that in very, very thin lines, the biquad filter is amazing. So there's really nothing to see here. It's impossible to tell how much noise you do or don't have because it's so filtered. It's gorgeous. Okay, so nothing to see there. Okay, let's take a look then at your roll axis. We do see some high frequency noise in the D term. However, the P term is completely well behaved, unlike one of the other videos I've seen that had all this high frequency noise in the P term. It's not unusual to see high frequency noise in the D term because the D term, the way it works, means that it amplifies noise. And in fact, we have found through experience that trying to make the D term trace look really smooth actually tends to result in worse flight performance, not better. So this amount of noise doesn't immediately strike me as problematic. I note that the magnitude of the D term is possibly half the magnitude of the P term, or seldom more than the P term, often proportional. And so overall, I feel, if I saw that the D term was twice the size of the P term, and if I saw that it was really dominating the PID sum, and by the way, that's certainly a good check. I don't always do that check. I just eyeball it, and let's just do that real quick. So we certainly can see some high frequency noise imposed on the PID sum. That's going to come across as a little bit of roughness in the motors, but I don't think that's necessarily problematic. And if we look for cases where things get a little more active, we don't see the D term flipping out like crazy, right? So nothing here looks too out of the ordinary. See, like right here, we can see the high frequency noise of the D term showing up in the PID sum, but we still mostly see the shape of the PID of the P term. So the P term is dominating, and that's what we want. So far so good. Here we've got a roll. Let's take a look at this roll and see what it looks like. By the way, we won't have any audio because this is a DVR recording with no mic, so no audio here. We definitely do have a little bit of a bounce at the end there. And so you can see that it is more than just one hard shake, one hard bounce, but it's actually like a shake or an oscillation, and we can certainly see that here in the gyro. Gyro goes positive, negative, positive, negative, positive. So that's the gyro going back and forth. It's also interesting to me that we've got this skip here, most like this flat spot here, where the gyro doesn't slow smoothly, but it actually almost stops moving and then picks up again. It does make me wonder if you pause the motion. Yeah, looks like you pause the motion of the stick slightly and then return it to center. So just looking at the stick here explains this little flat spot here. What is the P term doing? So as you begin to center the stick, the P term begins to, let's see. Yeah. So the P term is opposing the move the whole time and strongly opposing the move. That's probably Acro plus. Yeah, that's got to be Acro plus. Interesting. So let's take a look at this. This is the first time we've seen an Acro plus trace. Notice that the P term is crazy opposing the move, right? It's way opposing the move. It's like off the chart. And what I think is happening is that the Acro plus configuration is causing the PID sum to have less effect on the values that are output to the motors, and the stick is controlling the motors directly, which means that although the PID sum is saying, slow down, it's basically somebody's stuck a sock in its mouth, and it's going, slow down, and isn't being heard. So when we analyze Acro plus Blackbox logs, I have to wonder if when the stick deflection gets very far, we have to kind of ignore the PID sum to some degree, the PID term to some degree, because they're apparently still active in the background, but they're just being partially or wholly, depending on how much Acro plus you have dialed in, ignored. They're being ignored. So I have to wonder if it is normal in a situation where you're using Acro plus to see the P term opposing the move for pretty much the whole move, because the move is always going faster than the PID controller would like. That's the whole point of Acro plus. Okay? So I don't think we can read too much into this. And it's only as the stick gets back past what I think it's 70% deflection. Oh, that's it. That's why the gyro does this. So I think that what's happening is that as the stick gets past 70% deflection, this is the point where the PID controller kicks back in. That is fascinating. That is really cool. Yeah, above 70%, Acro plus is active, and then the PID controller kicks back in, and the P term says, oh, okay, speed up after all. Speed up a little bit after all. Whoa. Oh, the PID controller is saying, slow down. Acro plus, you're going too fast. And as the stick comes back, the PID controller, somebody takes the sock out of its mouth. And it goes, oh, hold on. Don't slow down that much. You slow down too much. And then it sets up this oscillation right here. So that's really interesting. I would have to defer to Boris, who I hope is watching this. Is this transition from the Acro plus mode, where the PID controller is basically just being ignored, is it normal for there to be this kind of a sort of a stutter step during that transition? Or is this a tuning problem? Because normally if I see this kind of oscillation at the end of a roll, I would say you either have too much P gain or not enough D gain. But I don't see anything like these oscillations here. That's not excess P gain. That's just the P term working. You know, it's starting to look like this surging, I call it. It's starting to look like it might be thinking about oscillating, but it's not there yet. And as we look through this trace, like we see lots of times like this where it's getting active. Nothing really going on there to explain why it did that. That's interesting. I thought maybe it'd be some prop wash. But okay, so it's a little active, no problem. And I'm just looking for oscillations. Most of the time it's not doing much. There's times when it gets more active, but nothing crazy. Yeah. So this looks like a pretty sharply tuned P term, but nothing in here really jumps out as excess P gain. So maybe you could stand or raise D a little bit. Maybe you could stand or raise D a little bit, and it might help tame that. But I'm not sure how much of that oscillation at the end of that roll is just an effect of the transition into and out of the Acro plus mode. I don't know, because this is the first one of these I've seen. And there you go. You get to be the guinea pig. You could try raising your D term. Your D term is kind of active. I'm not sure I'd want to raise it too much, but it doesn't look like it's going crazy. And you might add some D term filtering to help smooth out this. You do have some high frequency stuff, and you're definitely seeing these. If we watch the motors, see the motors jittering like this? That's definitely wasting some energy, so I don't know if we want that. We don't see it here. Here we got a sharp turn. No, is it a roll? Let's look. I don't know what it was. See, look, the oscillations here are getting tighter and faster. So this is starting to, again, I wouldn't say it's over the edge yet, but see how we've got this long period where the P term is doing these tight oscillations, and then here they get even tighter. And then they die down. Okay. That's starting to look like it might be a little too much P gain. I don't think it's there yet, but it's starting to get there. These are the sort of warning signs that you're getting close. Okay. You just did something. There's a bounce for sure. A big bounce there. See right here. 0. This is where the copter is stopped. See the gyro, the purple line comes to the 0 axis. The copter is stopped, and now it's going back. It's continuing. It's a stutter step. It stops, and then it accelerates again. And that's exactly what we see in the transition. See, look, the P term is opposing the gyro. They're on opposite sides of the axis. As the stick returns to center, the P term goes, whoa, whoa, don't slow down that much. Speed up. And there's a stutter. This is Acro Plus. Okay, so we've identified what's going on here, but I don't know how to tell you how to fix it because I am not an expert in tuning Acro Plus, and I hope that I'm gonna try to ping Boris on this and see if he can speak up. I am at 12 minutes now. I've talked about just your roll axis. Well, we found something really cool on your roll axis. I'm gonna stop there. I'm gonna leave your other axes. Let's just do a quick look at your other axes, just real quick. Looks okay. Yeah, same thing. It's sharp. The P term is definitely getting around, and the D term is a little more active, but that's okay because yeah. Now you're fine. Now you're fine. I don't see anything too bad there. And yaw, hello, yaw. Oh yeah, no problem. Yeah, no problem. Okay, there's my quick assessment. Everything else is good. Really curious about that other one now. So let's hope Boris chimes in. And thanks for your submission, and happy flying.